Hello, everybody. Thank you very much for joining us, and welcome to the OSLC Fest 2020. It's the best event to learn who is doing what with OSLC, and it's obviously also an event to kick off interesting conversations and to connect with other persons interested in OSLC. I encourage you to join the OSLC forum and also the OSLC Slack workspace, and you can find the link to access these resources in the description field of this live stream. This year's event will be a 3-day event with 6 or 7 talks each day. We will have in total 20 talks, including 8 talks from software vendors showing what they do with OSLC. For more information, you can go to oslcfest.org. My name is Axel Reichwein. I will be your moderator for today. And it's 6 a.m. for me here in San Francisco, but I'll do my best to stick to the schedule and make sure that no session overruns. So I really invite the audience to participate by submitting your questions to the speakers. We have an issue right now with the Meeting Pulse app that we originally planned to run in parallel. So therefore, the best is that you submit your questions to the Slack channel, to the general channel of the OSLC Slack workspace, and please give thumbs up to questions that you like, and I will then use the most liked questions in the Q&A sessions. Please use the hashtag OSLC Fest, which is displayed at the top left of your screen. And I want to thank Andrew Berezovsky, Jad El-Khoury, Jim Amston, Nick Crossley, and Gabriel Fernandez. Without their great help, this would not have been possible. Tomorrow, your moderator will be Jim Amston, and on the 3rd day, your moderator will be Andrew Berezovsky. So coming next is our keynote. I'm very pleased to welcome Dr. Juan Sequeira, Principal Scientist at Data.World. Dr. Sequeira is an expert in graphs, and today he will share with us the history of knowledge graphs. This is a very relevant topic for the OSLC community because as soon as we connect data through OSLC APIs, we end up with data that is described as a graph. So before we start, just a quick reminder again, please submit your questions to the OSLC meetup. Okay, very good. So you can use meet.ps/OSLCfest to submit your questions. That's the easiest. Then you don't have to go through Slack. So Dr. Sequeira, we can see your screen. Welcome to the OSLC Fest.
Great. I'm in presentation mode, just confirming that works, right?
Yes, please go ahead.
Excellent.
Perfect.
Great. Well, thank you very much. It's a true honor to be presenting to this group, and I'm really excited about this invitation. And we got 40 minutes, so let me dive in. This is the very common phrase that we hear all the time, right? Those who cannot remember the past are condemned to repeat it. And I have been fascinated by looking into the history of knowledge graphs in particular, and just history in general, which it's a topic I really love, because when I've been giving talks in the past, I ask people about the following, and it's really hard to go do here in a virtual setting, but let's virtually raise your hand if you know about the Dartmouth workshop, right? This was a workshop in 1956, organized by John McCarthy, and you had a lot of really important people like Marvin Minsky and Claude Shannon. And this was a summer workshop that was created, and this is where artificial intelligence was actually born. So I find it fascinating that there's all these really important historical landmarks, and it's common that people are not aware about this type of history. Now, also raise your hand if you're aware about the Japanese 5th generation project. The Japanese in the 80s, they decided to go build AI machines, hardware and software built on Prolog, and they were making all these big claims that they wanted to go do in the 80s. And a lot of this was just stemmed a lot of the work that we see that came out in the 90s and 2000s. Point being is, it's really interesting that that we're seeing a lot of junior folks and sometimes even senior folks, I have to say, who are not fully aware of where everything comes from. And it is, I have to say, personally, a bit frustrating when people start doing work and thinking that it's the latest, greatest piece of work that they're doing. But it's just a slight iteration with probably different syntactic clothing of ideas that have happened before. And I think it's important to understand this, not just from the cultural aspect of let's know what has happened before, but also because we do not want to reinvent the wheel. So just very quickly, who am I? So as mentioned, I'm the principal scientist at Data.World. Data.World, we're a cloud native enterprise data catalog with a lot of really cool data virtualization and federation features. And we're built entirely on a knowledge graph on top of all these knowledge graph technologies we'll be presenting. I joined Data.World almost a year ago through the acquisition of my company, Capsenta, which is a company I founded out of a spinoff from my PhD research at the University of Texas at Austin. Just a little side note, given the situation that we're all in here, Data.World is the largest open data catalog in the world, and we're hosting a lot of the coronavirus to COVID-19 data. If anybody wants to go and access all this data, it is completely open. It is free. Anybody can create an account, and that's part of what the mission of Data.World. We're a B Corp. I've been working on graphs and anything graphs and data integration related for over a decade now. And just as a quick note, at Data.World, we're hiring right now. So, but I do want to make sure that people know this history. This is joint work with Professor Claudio Gutierrez from the University of Chile. Actually, we've probably spent 2.5 years kind of looking at the history, and we've written an essay about this. And you can go, here's a link for the essay. And this is history, meaning that this is Claudio's and Juan's interpretation of history. So therefore, yes, it is subjective. Nevertheless, we were able to get in contact with a lot of the key players who made part of this history. And we're very, very thankful for all the reviews and comments that we received to make sure that we were being accurate with the facts and seeing if agreements or disagreements with our interpretation of history. So to start off, I'd like to say the early vision in computer science has been to create these intelligent systems that can integrate knowledge and data at scale. This is a vision in computer science. Now, I'm going to argue that this vision is now manifested today in this modern world by this thing that is being called a knowledge graph. And a knowledge graph is a term that was defined by Google 8 years ago now. Now, the point I want to make is that this isn't something new that Google invented. It is just the modern manifestation of this vision of integrating knowledge and data at scale. Therefore, what is this historical context? So knowledge graphs comes out around 2012. And what we're going to be showing is that there has been these two main threads and an intersection of them, the thread of knowledge and data that we see that arrives over in the 70s. And we're going to go through all these different eras. And there is like this Western civilization obsession of multiples of 10. So we are going to try to tag all of these eras by decades, even though we know that that is very fuzzy. So let's start. So the advent of digital age was the first kind of in the 50s and 60s. So one of the first things that we see is the need to automate reasoning. And this shows up with the logic theorists, right? So you have Newell, Simon, and Shaw. They come up with this first program, which is called actually the general problem solving program, which is their goal to be able to have a program that can take any problem and be able to solve it. And they would be able, and their input were going to be trying some theorems that they wanted to go solve. And this was kind of the start of the initial theorem proving. So then you have Robinson, who comes up with resolution, right? It's a unification algorithm to be able to apply a bunch of rule inferences and to be able to do the first type of theorem proving. Now, all of these types of ideas get implemented in a bunch of algorithms. And I think the first algorithm we see is the DPLL algorithm, which is kind of the basis for SAT solvers still today. Now, I find it fascinating, the idea of being able to do query answering comes from this time. And I find it also really fascinating how well written these papers are. So take a look at these 3 points. They said there's these 3 characteristics of the query answering system: the ability to accept statements of fact and store them in its memory, the ability to search and store information that it can be recognized, for a particular query, and the ability to be able to present that answer from memory and deduce reasoning logical responses from relevant knowledge if it's not explicitly able. These ideas of query answering go back from the 50s. Then you have systems like ELIZA at MIT that they wanted to go do like the chat between a human and a computer. The next topic that we see is the idea that the search space is very, very big, and we need to be able to deal with these complex search spaces. That's when Dijkstra in 1956 presents the Dijkstra algorithm, and this is generalized later on by Bertrand Raphael with the A-star search algorithm, right? So this was almost 10 years later where this was generalized. Third area is the idea of being able to retrieve information from structured sources. Bertrand Raphael, as you see, is a very important character at this time. His PhD thesis was specifically to create a computer program that can extract semantic information from unstructured text. This has always been kind of an era of early on, is to be able to understand language. Fourth, we need to have languages and systems to handle data. The first database was by Charlie Bachman, the IDS, the Integrated Data Store. And guess what? It was a network database. It was a graph database at its time. Now, what happened at that time is that you had to have a language very tightly connected with this database. And this led to be able to have all these types of standards. So you had Codicil was the first consortium to be able to create standards, which led to COBOL, right? COBOL was that first language that inspired languages like SQL because you wanted to have an English-like computer programming language. Then finally, what we see is this need to be able to represent knowledge in a graphical form. Now, Richens is actually a botanist. He presents this idea that he wants to be able to translate languages. And he says, I'm going to refer to the construction of an interlingua in which we remove all the peculiarities of a language. And I'm going to call this a semantic net. The elements represents things and qualities or relations. So the idea of representing language as a graph comes from this era, 1956. But the goal is to be able to, again, understand language. And then this idea was now being introduced in the computer science terms by Ross Killian in his PhD thesis. So in this first era, what we realized is that we want to be able to, the importance and the possibility of automating reasoning, we have to deal with large search spaces, we want to deal with natural language, we have this potential of semantic nets as a way to represent as an abstraction layer, and there's a lot of data that we want to be able to manage. But as you can imagine at that time, there's a lot of physical and technical limitations about hardware, and there's all these gaps between understanding the human language and the data. So this is the first kind of major things that we see during this time, right? Semantic networks, the resolution principle, the general solved problem, shortest path, COBOL, network databases. And now we enter the 70s, where we enter this era of the foundations. So now we're going to start talking on the data side, on the knowledge side, and then on the intersection of knowledge and data. On the data side, as you can imagine, one of the biggest kind of contributions at this time is Codd and his relational model. The idea of the relational model is to provide this notion of what we call data independence. So what happened before with these network databases is that the program and the data was tightly coupled. So if you had data and you change the structure of your data, your program would fail and you had to go rewrite your program. So you wanted to have this layer of abstraction, a higher level of abstraction, where you have this independence that I can model things, define things in the sense of relations, and then this can then be separated about how the data is physically stored. That's why when you do A join B, you never say if it's A, I join B first, or do B and join, and with type of join algorithm, that's that independence that we have. Second, we see Peter Chen presents the entity relationship model. And what's fascinating is that the goal of the ER model from the beginning, as it says here in this abstract, is to be a basis for unification for different views of data, for the network model, for the relational model, for any entity set model. So there is already this view that we're going to have different forms of data, and we want to be able to have a unification model on top of them. Then these kind of theoretical approaches of managing data were now implemented. So IBM presents System R, the first relational database management system at IBM, and at the same time, Michael Stonebreaker and company in Berkeley implement Ingress. As you know, Ingress is what ends up becoming Postgres later on. So this is what we see on the data side. On the knowledge side, the most important kind of event that happened was William Woods presents this paper called What is a Link? And it's really a critique to this idea of a semantic network. He's saying, look, everybody is so fascinated about semantic networks at this time, but what does that link actually mean? If I say that a person lives in a city, what does that mean? Does it mean that all people live in a city? Does it mean that at least one person lives in a city? So what are the semantics behind these links? And this spawns all this research, and you see Marvin Minsky presenting the idea of frames as an answer to be able to formalize the representation of knowledge. And then from there, another idea that comes up is John Sowa. John Sowa is at IBM at this time and presents this idea of conceptual graphs for databases. And this is fascinating because this is what we're doing today with the idea of knowledge graphs. Is he presents conceptual graphs that can describe data according to the user's view and access data according to the system's view. There is this other notion that we call today ontology-based data access or ontology-based data integration. This is exactly the same back to the early 70s. Now, Pat Hayes comes around and he says, look, we can actually formalize semantic networks and ground them in first order logic. And this was the big aha moment of the time, that we could use something that we already know, first order logic, and be able to represent semantic networks in that. And this is going to lead to a lot of work in the 80s. Now, in the combination of data and knowledge, we see Bob Kowalski presenting this idea of programming, of logic programming. Now, there's this big battle of people trying to figure out, well, should we have languages that are more imperative, should be more declarative? And Bob Kowalski says, no, logic is the language. Logic is the language to represent the knowledge. Logic is the language that you actually go program everything. And then Bob Kowalski works a lot, travels every summer to France to meet with Alan Kommenauer. And Alan Kommenauer is the person who comes up with Prolog. And from there, we start seeing this era of the sort of expert systems, right? Mycin is the most popular expert system that comes out at that time, doing backward chaining, trying to be able to rewrite queries, rewrite rules. And this is applied a lot into in the biospace. Now, a very important workshop, an event that occurred, I think in 1977, organized by Gallier and Minker, was this workshop that brought together folks from logic and databases. Several important papers were presented at this workshop, which are groundbreaking today. So Ray Ryder presents the whole closed world assumption, and Keith Clark presents the negation is failure, which is actually with the first version of Sparkle that came out, the graph query language for RDF, there was no negation operator. So the only way to go to negation was doing negation is failure. So what we see at this time is that we realize that we need to have an independence, this data independence, and we can formalize semantic words and logic. But on the data side, you're going to see that there's this need to be able to deal with more flexible data representations. And in the knowledge, there is this trade-off that people start discovering. So here are kind of the things that we start seeing during the 70s. So now we'll dive into the 80s. We start understanding how to manage data and knowledge together. So on the data side, well, this is the era where, right, Microsoft is coming out, all the big companies, Oracle kicks off, Sybase are these big companies, and the relational database industry is really growing. But there's a lot of people who are saying, look, the relational database can't be a silver bullet for everything. And in particular, because we generated all this data independence, now things got too disconnected. So you're saying we have in the 80s, object-oriented programming languages come out, Smalltalk and so forth, right? So you start writing code with an object in mind, and people start saying, why do I have to go through this layer of a relational thing to translate into a relational database? Why can't I just store and manipulate my object and my code as in my database together? And that's where this era of object databases come around. And this is a big hit, right? You see AT&T comes up with their ones, Hewlett-Packard comes up with their other ones. This is Texas Instruments so much. So all these is what's happening more in a lot of the industry and kind of joint industry academic side. From the very kind of theoretical database on the computer science side, we have Alberto Mendelsohn, right? Alberto Mendelsohn plays a huge role on the theoretical side of data. And he's already starting to look at the query languages for graph representations of data. And this is when you start seeing, how do I deal with recursion? And then also Alberto with his other student, Mariano Conces, they start thinking about these languages where you can put regular expressions on top of to be able to qualify paths. The work that Alberto Mendelsohn does with Mariano, with Peter and Isabel are the foundations for modern graph query languages today. So things that we call property paths in Sparkle, or RPQs, or all these things that are in all the other graph query languages, like in Neo4j, Cypher, and so forth. All of these are founded in the work that's done by Alberto Mendelsohn and company during the 80s. Now, on the knowledge side, what happens is that we have this understanding that we can now represent semantic networks. We can represent knowledge in this graphical representation of knowledge and give it a first-order logic foundation. But first-order logic is intractable on what we realized at that time. What Brockman and Levesque realized is that you don't need all of first-order logic. All you need is a subset of first-order logic. And this becomes this era of understanding the trade-off between the computational complexity of reasoning and the expressive power of your language. And this is what gives a rise to this era called description logics. And you start seeing all these different languages coming around. Everybody is saying, well, I can do this, but I can't do this. And they start kind of competing with their language. So the first one language that we see is KL1, based on the work of Brockman and Levesque. You see languages like Loom, which is a language comes from University of Southern California at ISI. And the group at ISI is still very, very strong in the knowledge graph world right now. You have AT&T presents their language called Classic. And there's different types of approaches. For example, Michael Kiefer presents this idea of F logic, which is a combination of logic with frames and object-oriented influence. Now, on the combination of data and knowledge together, we see this Japanese fifth generation project come around. The Japanese during the 80s, they were eating up the world in cars and electronics, and they wanted to eat up the world in software. And they said, well, they're seeing the rise of all these expert systems, and this is the hype of AI, and they wanted to create this hype of AI, and they said, we're going to create these hardware and software AI machines. And because the world in the West, the US was running on Lisp, they wanted to follow the European world on Prolog. And their goal was, in 10 years, we're going to have automatic translation between languages, all these amazing things that they were promoting that they're going to do in 10 years. And this scared everybody around the world. So the US, right, this is during the 80s, this is the Reagan era, right? Everybody is free market and everything. But the US actually opened up and said, let's create a consortium and let's let companies work together and create a monopoly so we can go fight the Japanese. And they did this. And they created this consortium called MCC, the Microelectronics Computer Consortium, which ended up being here in Austin, Texas, where I am. And many different things came out. So in the UK, you have the ALVI project. And there was another project in Germany called I forget the name, it was in Munich. All of these to be able to to come up with parallel computers to be able to do AI reasoning, to do information integration that we start seeing. Psych, as people may know, probably the largest kind of AI project has been since that time, since the 80s, has been trying to build the gigantic common sense knowledge base of the world, and they're still around. You start seeing kind of these rule-based and production systems like OPS5. The REAT algorithm from 4G's PhD dissertation is now presented. Any rule-based engine today still runs on the REAT algorithm or a dialect of it. Actually, my PhD advisor, Dan Maranker, his PhD was to take the REAT algorithm and parallelize it. And he created the TREAT algorithm, which is exclusively to be able to compete against the Japanese. You see the things like the connection machine from Danny Hillis at MIT to create these supercomputers that can do AI. Funny story, Danny Hillis does a lot of amazing things. And one of the things he's done recently, fairly recently, is that he founded a company called MetaWeb. MetaWeb created Freebase. Freebase was the foundation of Google's knowledge graph. This is when we start seeing deductive databases come around. Deductive databases, what we realize is that putting a system like Prolog on top of a relational database wasn't going to be that easy. So the idea of kind of restructuring and thinking about this natively, and that's where deductive databases come around. So systems, I would argue, like what you're seeing, RDF graph databases that can do reasoning are just a form of deductive databases. You have the first type of logic-based language, LDL, also from MCC, and then you have the language called Datalog, which is a subset of Prolog. So I'm going to jump here quickly because we're running short on time. These are a lot of the things that we start seeing around the 80s, right? And actually, for example, SQL comes out as now being the language of the 80s. So what happens in the 90s? In the 90s, we have the web, right? So from an academic point of view, Alberto Mendelsohn shows up and he's already starting to how to study the web. He actually comes up with the query language called Web SQL, right? And you think about if we think about what happened around in the late 2000s with all the linked data on the web and the idea to be able to go query the database if it were a database, this notion's already start thinking about when the web comes out. And people really start thinking about how to study the web as this computational system by itself. That's why we start seeing XML. XML comes in 96, the first version. The first version of RDF is presented in late 90s as a way to be able to represent kind of metadata. And then you have different types of models, right? OEM is a different type of model for semi-structured data. Then you start seeing these projects between academics and industry on information integration. There's all this data now starting to be produced and we want it to be integrated. So you have, and InfoSluice is another big project also from MCC. And then because we start generating data, we need to go analyze data and e-commerce starts to pick up. We need to do analytics. And this is when we start seeing data warehouses and OLAP. On the knowledge side, we come into this AI winter. Remember, the Japanese had all this big dreams and it failed. All these expert systems were coming along, but they were very brittle and they could not scale. It was really hard to set up these expert systems. And people just started they lost faith and lost funding, and then that was it. That's how the AI winter enters. But a lot of people continued to study the problem and they realized that we have this knowledge acquisition bottleneck was the name. And people started getting together thinking about this. And this is when you start hearing this era of ontologies, a famous paper that presents what is an ontology. By the way, Ton Gruber founded a small company called Siri, and Siri was acquired by Apple. You start seeing these people trying to figure out all these methodologies about knowledge representation, about creating ontologies, about how to acquire and manage knowledge, right? The CADs, methontology, Keats, and systems like Protege that are still used today to create ontologies. Now, on the combination of data and knowledge, what we start seeing is this idea of being able of the deductive databases. This really starts to mature during the 90s. And we start seeing all these workshops focus on deductive databases, on knowledge representation meets databases. And then we start seeing the first ideas of being able to put semantics on the web. So Jim Hendler with his student Jeff Heflin, they present this idea called SHU, the Simple HTML Ontology Extension. That the idea is to put some semantic tags on top of the HTML to be able to understand what these pages actually mean. Now, what's interesting is a lot of people are starting to think about this at the same time, because the web is a very popular thing, and we realize that we need to have a way to deal with knowledge. And we want to be able to do this, acquire knowledge, do this at a scalable approach. And the web is this medium to go do this. We want to be able to go share knowledge. So you have things about like the KQML. You have the US starts this program called DAML, the DARPA Agent Markup Language, right? And this is one of the foundations of what's going to become the semantic web. The Europeans are also thinking about this at the same time, and they have this they generate this thing called OIL, the ontology inference layer. And this is all based on the description logic work that is being done a lot in Europe at that time. So what we realize is that the web is really starting to grow and there's a lot of new mediums coming around, but there's all this, the computational power was still not there. And then we have all these limits on the logical techniques for doing reasoning. So here are the things that we start seeing during this time. So now we enter the era of the 2000s. And what's the big thing? Of course, we have big data and NoSQL, right? So this is MapReduce, Big Table gets introduced, Dynamo gets introduced. These are the big things that come out very quickly from the Amazons of the Google of the world and really revolutionize computing at this time. And it seems like yesterday, but right, this is almost 20 years ago, this came out 15 years ago. From the academic side, people are really focused on figuring out how to automate data integration. All this work on schema matching is occurring constantly, right? You have all these approaches, ontology-based schema matching. You have these workshops on ontology matching, and then the theoreticians arrive to be able to study data integration from a very foundational theoretical perspective. So you have this notion of data exchange, and these books on data exchange are being presented during this time. On the knowledge side, people are just trying to now implement these systems that can go do reasoning, right? Systems like FACT, systems like Hermit, or like Pellet. Pellet is a very, very popular system, which actually is the foundation of Startup, the knowledge graph database. But you know what, in my opinion, is that we have the rise of machine learning and especially all the work on deep learning, and this really opaques all the advances that the pure kind of GoFi, the good old-fashioned AI folks are doing on the knowledge side. On the combination of data and knowledge, what we start to see is this idea of the semantic web. The idea of being able to provide a semantic layer on top of all this data, all these web pages on the web. And that's when the Europeans and the Americans get together and they create this Daml plus oil at the beginning of the 2000s. And then Tim Berners-Lee says, well, let's go do this in the W3C. And they have this semantic web project, which starts creating these recommendations about the the web ontology language. They start defining and building on RDF and have Sparkle as the query language for RDF. Now, I like to think about it this way. This is my perspective, is that around the mid-2000s, everybody, this whole semantic web project got really excited, but there is so much influence from the academics, especially from the knowledge representation theoretical side, that the focus of the semantic web really became very academic and became all about ontologies. So I think there was some frustration that, hey, it's not just about this ontology thing, it's about the data. And that's when this whole idea of linked data starts coming around 2006, 2007, about, you know what, let's keep it simple. Let's put data on the web and let's start connecting it together, which was the original vision of a semantic web. That's why RDF was created from the beginning back in the late 90s. So you start seeing things like DBpedia saying, well, let's go get the data. Where do we get massive amount of data? Let's go extract the structured data from the info boxes in Wikipedia. And they start saying, let's start looking this together. And the idea of the linked open data cloud starts to grow. You also start seeing these systems like Yahoo Search Monkey that were the first ones to create these rich snippets of information. When you look at search, you want to have something, not just your 10 blue links, but a little bit more information. And that's through this Yahoo Search Monkey. Freebase, remember, as I mentioned before, comes around through MetaWeb. And then this linked data cloud starts to grow. And I think this is how we start to demonstrate that we can now start integrating data, and as Jim Hendler always says, a little bit of semantics goes a long way. We start combining this data and knowledge on this medium called the web. And this is the first manifestation of this modern aspect that becomes the knowledge graph. So we start really thinking about data in a much bigger way. And yes, we enter the era of neural networks, and that starts to opaque a lot of the advances in the knowledge world. And the biggest limitation I see right now is that we are not combining very well yet the reasoning aspects and the statistical methods. And this is a very popular topic right now. So that kind of the advancements that start leading us already and into the knowledge graph. So where are we now? Just to kind of wrap up, and hopefully we can leave some time for questions, is in kind of early 2000s, the very ironic thing is that people were against creating this one gigantic knowledge base. Everybody continues to, in a way, critique a lot of the work that Psych has done since the 80s. But what's really ironic is that all the big giants, Google, Microsoft, Yahoo, Yandex, they all got together and they said, let's go create one schema that rules it all. And let's make people go add markups using the schema that we have provided. And they have been able to accomplish this very, very successfully. Now, it's not a completely centralized approach, right? This is a very community-driven approach to do this. And I think that's one of the most important aspects is the community. But then you have companies like Google, Microsoft, who are incentivizing you, to be able to create these markups. So the irony is, there's never going to be a one ontology that rules the whole world, but there is one right now. Then you start seeing Wikidata, like foundational, let's go present the data as it is, the structured data. Knowledge graphs, this idea that Google presents in 2012 that starts kind of get everybody really excited, the things not strings approach of Google's knowledge graph. And then graph databases start to gain so much popularity, right? The whole NoSQL movement is the one that spawns this out, but graph databases, as you can see, are getting so much popularity. And we start seeing now all the big companies applying sorts of knowledge graphs, of being able to have a very fixed way of representing their most important data. So to kind of summarize, right, knowledge graphs comes around 2012, and we have these 5 different kind of pillars that we observe: the graphical representation of knowledge, automating reasoning, search in spaces, understand unstructured data, and being able to manage with data. We have all these different kind of advancements that comes out from the 50s and 60s. And then we start seeing in the 70s the idea of knowledge and data and its combinations of it. You start having all this, the Japanese 5th generation project really spun the need or the want to be able to combine logic and data using Prolog or Datalog, and this spuns all this excitement of expert systems and Datalog and deductive databases. Yes, we went into the AI winter because we overpromised, but a lot of people went and continued to study what happened. The knowledge acquisition bottleneck comes around. The web is the main thing of the 90s, generates all this data to be able to do data integration and analyzing and doing analytics like OLAP. We're starting to get more and more data. Big data comes around. We need to go deal with so many different structures. NoSQL comes around. We're now taking this idea of knowledge and putting them on the web, and that's when the semantic web comes around. And now we have schema.org and Wikidata. And I'd like to argue that at data.world, just to kind of put in a small plug for our company, we really want to take this to the next level of combining data and knowledge together. So throughout this history, we've observed 2 important threads. One is we want to represent and manage data and knowledge together at a large scale. And we want to be able to integrate the most diverse and disparate sources of data. And we also want to make this data accessible to normal users. So to wrap up, Claudio and I we concluded our entire manuscript with the following. So if we were to summarize in one paragraph the essence of what has happened in the last half a century, is that data has been traditionally considered a commodity. Data is literally like your bits, your matter, but it has no semantics. It really has no meaning. If I tell you 43, and that's it, what do you know about 43? Well, you know it's a number, right? It's a positive number, but you don't know anything else about it. It's just it's just matter. Now, knowledge has been traditionally conceived as that immaterial object. It's what's in people's mind. It's what's in our language, and that's how people communicate. So data by itself really doesn't mean anything. It could potentially mean something, but it needs that knowledge. Knowledge by itself can provide that meaning, but knowledge by itself continues to be this abstract, immaterial thing that lives in our mind and languages. We need to be able to ground that together. And what we believe is that it's destined that data and knowledge should be bounded together by computing. Is that we want to be able to combine data and knowledge together to be able to provide meaning. And that is the whole goal of a knowledge graph. So if you're going to ask me, what is a knowledge graph? It is the modern manifestation of integrating knowledge and data at scale in order to provide meaning. And with that, thank you very much. Back to you.
Yes, sorry, I was on mute. Yes, I can hear you. Dr. Sequeira, thank you very much for this overview. Fascinating keynote, and I think you did an excellent job of summarizing this very complex topic. Let me quickly see which questions we have in the Meeting Pulse app. We don't have much time for the Q&A. We have already reached the 40-minute mark.
Yeah, I understand. Anyway, my Twitter handle is @JuanCicada, and feel free to reach out. We can take this conversation live on social media. Love to.
Absolutely. Let me quickly go over one question. So one question that I'm seeing here is, with the lessons learned and new advances such as cloud compute, big data, parallel RETE and CRDTs, and better formal understanding, which old ideas are worth revisiting?
All right, so a quick answer to that. For me personally, I'm biased, right? For my biased opinion, what we are not doing right now is looking at the work of the 90s of the knowledge acquisition bottleneck type of work. But at that time, there was this role called the knowledge engineer. And I think that is something that we need to revisit today. And actually something we're pushing. If you go to knowledgescientist.org, I'm really pushing for this new role. Just in a nutshell, what I think about it is, if you look at software engineering, you know what a team is. You have a product manager, you have software engineers, you have GitHub, you have Jira, you know how to do software. We don't have the equivalent for data, right? So and these are all disconnected. Who is the product manager of a data team? Who's responsible for data products? Who gets fired or hired or promoted because of that? We don't have that right now. And because we need all this data, garbage in, garbage out. If we don't have a way to manage the data with people, with the processes together, we're gonna fail. I completely agree with it. That's what I truly believe. And I think we need to stop thinking that we can automate everything. We need to understand how to put the human in control. And it's an interesting balance that we need to go learn a lot that was done in the 90s.
Thank you very much, Dr. Cicada. I will end here in the interest of time. Thank you very much again for your keynote. Excellent.
Thank you for inviting me. Appreciate it. You guys all have a great day.
Thank you. Thanks again for joining. I noticed that one question in the Q&A was if the slides will be released later. So that depends on each speaker, but normally, yes, they do get released and they will be available on OSLCfest.org a bit later. And I'll move on to the next speaker. So our next speaker is Dr. Jad El-Khoury. He's a researcher at the Royal Institute of Technology, KTH, and he also runs a consultancy firm on tool interoperability. Dr. El-Khoury has been involved in OSLC efforts since the early days, and he's one of the leading contributors to the famous Eclipse Leo open source project. Today, he will give us an update on the state of OSLC adoption and the state of OSLC adoption in commercial software applications. So just a quick reminder, please submit your questions on our Meeting Pulse app, which is at meet.ps/OSLCfest, and then we'll go over your questions in the Q&A session. Dr. El-Khoury. Oh, all right. I see you're back, Dr. El-Khoury. Let's switch to your screen. Gabriel, can you? We need to switch the presenter roles, I think, before we do that.
I can't seem to be able to share a screen, Axel, yet.
Okay, just a second.
Right. You can hear me, right?
Just a second. Yes, I'll make you presenter then. No problem.
Yep.
You should be presenter now, and you should be able to share your screen.
Getting there. You see my screen, right?
Yes, we can see it. And well, welcome to the OSLC Fest. Please go ahead. Thanks.
Yes, thank you. Just need to get my screens in place. Yeah. Okay. Thank you, Axel, for giving me this opportunity. So today I want to share like a summary of a recent survey I did on the adoption of OSLC of the standard in commercial applications, in commercial software. Just to give you a bit of a background of why I did this survey, we wanted to analyze the suitability of how OSLC can be used as an integration mechanism for cyber-physical system development. And the assumption here is that for every of the disciplines involved in cyber-physical systems development, there are well-integrated development environments. If you take hardware engineering, there are applications, there are platforms that support this discipline, same as for software, same as for systems. Even though OSLC can be used for so integration within each of the disciplines, we wanted to focus on sort of more of the vertical integration. For example, for requirements, if you have your systems requirements, can we use OSLC to trace these requirements, the high-level systems requirements, down to the specific requirements that are to be developed by the hardware engineers and or the software engineers? Now, how these requirements can be integrated within the discipline, that also OSLC supports, but that's not really the focus of that analysis. So that's sort of the motivation to do this survey. And one way of doing that, we thought, okay, as a first step to do this analysis, we really wanted to understand what is the support, what is the current state of practice of OSLC? How is OSLC being used today? What do the providers, the vendors of applications, of software tools, engineering tools, what kind of support do they do to make this, will it fit with this vision of using OSLC in that sense? So we just needed to establish the current market for that. And part of the report, I also sort of tried to reflect over, given the survey and over the experiences of using OSLC, what are the issues we've been facing? What are the common questions we always end up having to answer when we try to propose an OSLC solution? And I will focus mainly on the survey in these 20 minutes, but I think I'll just give you some pointers on these sort of general questions that keep reappearing when we discuss OSLC. And I'll try to wrap up with some, what I think is the future directions. Where should OSLC head, at least if we want to sort of achieve this vision of integration for cyber-physical systems? Practically, I think for you, and definitely for me, I think it's been great to do this survey because it really helps me answer this question that I always get. Okay, this OSLC sounds really useful, but how well adopted is it? Who's implementing it? What are the vendors that provide it? And although it's in my memory here and there, I mean, it's great to have this list of tools where I can just pull it out and show you, okay, here is the state 2020 of how OSLC is being adopted commercially. These are the kind of integration scenarios that our vendors are supporting. Another question that also appeared, I think, when we had this fest, actually 2018, if I remember correctly. Okay, two applications can support OSLC. Does that mean these two applications can interoperate? And it's, given that OSLC doesn't really specify the minimum requirements, it's really hard to answer that question just by knowing that two applications support OSLC. So you really need to know what kind of features are supported by the application. So I went in the survey in detail enough to be able to answer that question. If I have applications and I have a particular integration scenario, then I should be able to, with the survey, answer the question. Okay, these match. What the services of application A are provided are really what the application B needs for the integration with OSLC. This is the current, just to note, I just finished this survey, but I hope I can keep this alive. So the more I know about new applications, I hope I can keep the survey up to date with new ones. And definitely, I haven't covered all the applications. So what I did is I actually simply went out there and tried to find all possible applications that have some documented support of OSLC. You can see here on the right the list of applications that I found. This is not a complete list, but this is the ones I really tried hard to find ones, and I already discovered that I missed a couple. So I'm going to keep this updated. I didn't go for any prototyping solutions, definitely nothing to do with research applications, research results from projects. I wanted really sustainable kind of, to give a fair comparison and to have a sort of a sustainable survey. I really went for documented support. So I actually looked at user manuals to know that the vendor is guaranteeing this kind of support. If it's in a blog or if it's a research article describing what they do, I didn't want to take that material in because that changes over time very quickly. Just because you have a prototype doesn't mean you can purchase that result and start using it. Even though I'm an academic myself, I know how far research results can go before they're really in a product. So I sort of didn't include that, and that's not a big deal because really I wanted to see the trend in commercial support, committed support, and including that will just clutter that picture. And that's why you can see that I've only selected 23 applications to include in the survey. Most applications are just general engineering software, like design, modeling, kind of analysis tools that you will see if you're developing cyber physical systems. There is 9 sort of larger platforms, ALM, PLM platforms I found, and then I found 2 middleware. And by middleware, I mean not tools that an engineer will use to create new artifacts or do any kind of design activity. It's really just a facilitating tool that helps you with the integration with OSLC. And I've color-coded them if you want to quickly look at who I found. So you can already tag me if you're listening and you found that your tool is not there. I'm more than happy to include it in the survey. One positive thing I found is that most of this integration is actually, or the support is actually native. So the vendor of the tool is the one providing the OSLC integration. And that's actually a surprising positive news. 3 of them were just third-party tools. I mean, they're still commercial and sustainable, but they're not provided by the vendor themselves. One aspect, which is actually one end user, they had a need to integrate using OSLC. So they developed their own adapters in-house. But they also chose to share this sort of adapter as open source project with quite good documentation. So that's a good example of where we, the end users of OSLC, and not only the tool vendors, can sort of contribute to the standard, to the OSLC community by sharing your results and software. Most applications used, of course, the existing OSLC 2.0 standard, and I found 2 where they say they support the ongoing, which is still not a finalized standard, the OSLC 3.0. I think that was interesting to see that there were already 2 out there. My survey, because I wanted to be able to go into the details, I really sort of structured the survey based on this structure of the standard. So in the big picture, I wanted to see if there is support for OSLC server capabilities and or support for a client capability. And then within each, whether you're a server or client, I really went to the specific features of OSLC, creation factory, query capabilities, those delegated UIs. Does each application, do they provide it or not? Or do they do partial support for it or not? Similar for client. And then also try to cover, okay, which of these domain specifications are covered today? Just to get a big picture of which ones are interesting and which ones are not. So if I just go quickly, and my point here is just to show you pointers on this survey, just to give you an idea of the state of OSLC today. I think it will be interesting. If you look at the bigger picture, actually, just as whether they provide server or client support, most applications, or all applications, I would say, except 1 or 2, provide server support, which was a bit, 40% were only servers. They had no interest in, they were not designed to consume information from other tools, which I felt was a bit selfish. I will go back to, talk about this a little bit later, but most of them were servers. Only 2 applications were only OSLC clients with no server support. One of which is IBM Engineering Insights, or Realm, if you're the old name. But that's not strange because it's a typical analysis tool. So it has nothing to provide. It's only a consumer tool. So there's nothing really surprising here, except that this, for my own at least, the reflection that if you're a server, I mean, if we're talking interoperability and you're only a server, which is, 40% were only servers, that sounded sort of contradicting. Why wouldn't you want to integrate and consume from other tools? But after some reflections, I realized, I mean, maybe that's not a bad thing, because I mean, the main thing is to be a server, to provide access to your data, to break that silo of isolation of the data, which means you can be that tool can be part of an integrated tool chain. Other tools can consume your information. Now, whether you choose not to consume from other tools or not is just a local limitation. So I don't think anymore it's a critical issue that we have tools that are only servers and not necessarily consumers. Worth noting, of course, that I'm only talking about what is documented. So it could be that these tools are consuming from other tools, but that's not what I found in the documentation. So generally, I found, with experience, that people are very happy to provide servers, but maybe reluctant to be consumers of data. Maybe it's not a bad thing after all. It's really just a local problem in that sense. As long as I have access to your information, that's fine if you don't want to consume mine, I think. Let's go deeper a little bit, look at the server capabilities. You can see here on the right, just some statistics on exactly which capabilities are supported in terms of numbers. I assume you know a little bit about what these capabilities are. I don't have, unfortunately, the time to explain them. One surprising finding I found is that the EU capabilities, those capabilities that let a user, access the graphical user interface of one tool from another to create traces and to find these links between tools, that's really very commonly supported, and that's a positive news. What was surprising is that these REST operations, the creation operations, the query capabilities that really allow machine-to-machine integration, they're still supported, but they're relatively speaking less. We're talking about 7 or 6 applications that provide that. And that's a bit surprising because, you know, when we talk OSLC, it's all about REST and RDF and all these technologies, but most vendors are not providing that. They're really providing the capability to create links. And that's, again, I mean, maybe I'm adjusting my opinion after the survey, but that doesn't matter. Maybe the most important thing for us is that we can create those links. And without the EU capabilities, we can't even create those. We can't even let the user create those links, the traceability links. So again, this is a good news. At least I'm realizing that, you know, EU capabilities is the most commonly provided, but also that's the most important thing. Authentication and discovery were very widely supported also. And I sort of found a correlation that if you do authentication and discovery, you're sort of, at least according to the documents, you're trying to integrate with IBM Jazz products, because to do that, you need these discovery capabilities. Not a one-to-one 100% correlation, but at least that's what you see in this one. And what reinforces this idea for me is because, you know, most of these authentications are still based on OAuth 1.0, which is quite obsolete. Why would you do that if it's not because you want to support with Jazz, which is still based on 1.0 when it comes to external integrations? Jazz supports Jazz OpenID Connect, but if you want to do sort of external integrations, I think it's still OAuth 1.0. I could be wrong there. So that's an interesting finding. I think we're still sort of centered towards Jazz applications. Resource shapes have limited support, at least according to the documentations. Maybe they're being used, but at least they have no end user usage. So that's why maybe they don't talk about them in the implementation. It could be a part of the implementations, but they're not talked, you know, they're not in the user manual, let's say. That's the only thing I can say. There's no support for attachment capability, which is a new thing in 3.0. Not so strange, being a new standard, a new version. And when it comes to TRS support, tracked resource set, there were only, you know, the IBM products and any tools that are really targeting IBM or Jazz-based products. They're the ones that provide TRS support as a server. Very similar pattern actually when it comes to the client. So I won't repeat myself, but as consumer of OSLC, I mean, if you're supporting OSLC consumer, if you're supporting that, then again, creating traceability is the most important, most common thing being supported. Less common is to do the REST operations. And the only TRS client I could find is IBM Engineering Insight, which is, you know, the old RAM. So there's nothing surprising there either. How am I doing on time? Okay, when it comes to the domains, these are sort of the domains, I think the OSLC domains we have. Most of them are very commonly supported, and that was good news. The most common one being change management and requirements management, which is not so strange. These are the most lifecycle kind of artifacts you want to connect to. Asset management and automation, hardly any access, you know, one support from each. I think that's interesting for the OSLC community to see, okay, what do we want to do with this when it comes to the standards? Are they useful, or is there something else we can do about this? Something that I found interesting, and I was surprised, you know, when it comes to being able to define your own domains, especially if you think of PLM, ALM tools, these tools really give you the option to model your own information. Yet the possibility to give the designer or the PLM administrator the possibility to define own OSLC domains was, relatively speaking, limited. And it's an interesting finding. So even if you have an ALM that is very configurable, the possibility to go beyond what OSLC domains provide was more limited. And yeah, I wonder why. It could be, one speculation is that, you know, if we focus on these delegated UIs, maybe it's not so important what the domains and the specific information in them, because that's only relevant when you talk about RDF and the REST services. So that's one reason there's no focus on giving you the option to configure your own domains or define your own domains. Finally, I tried to look at sort of what kind of integrations, just to look at these trends, you know, when they're in the documentations, what kind of integrations are being provided by these vendors. Most documented integrations, again, are focused on IBM Jazz, which is sort of the reference implementation when it comes to OSLC sort of large-scale solutions. So there's nothing surprising there, really. What I found interesting was that vendors that provide both PLM and ALM systems, they're providing an OSLC solution for their own integration within the same vendor. That was a positive thing. So even if you own a PLM ALM system, even though you could potentially do a more like a tighter integration between them, the vendor is still going for a looser integration between using OSLC. It could be because these platforms maybe are not using the same technological space, etc. So even though you're still owned by the same vendor, maybe it's still the easiest way to do the integration is OSLC. But I think it's a good thing for us, for OSLC, to have this. I'm just sharing here some examples of Siemens Polarion is integrating with Teamcenter using OSLC. Of course, IBM Jazz and PTC integrating. These are the three findings. I think that was quite interesting finding. Okay. So this is sort of quickly the survey findings. In the report, I tried to also collect some issues, questions, or sort of qualities of things that keep recurring when you try to propose an OSLC sort of architecture. People find it interesting, but there's always this, yeah, okay, but, and then there's always these recurring questions. So I tried to sort of list sort of the strengths and benefits of OSLC towards their limitations. And I won't go through them all, and definitely not in the details, but I'll just lift a few that, I mean, people found OSLC as a obscure new kind of standard at the start, but they really find it interesting as an approach and a little bit sort of controversial. But in the end, it's really just based on REST pattern, which is very common, very, very usual today in software architectures. So that's something to keep reminding users or new users of OSLC. It's nothing but, well, not nothing, but the one big cornerstone of OSLC is using REST, and that's nothing controversial with that. Together with that, OSLC is based on RDF, which is really, I think you mentioned it before, like it's quite an obscure niche kind of academic approach to it, which is sort of, I mean, practically it's limiting because you can't find enough competence in that technology. Definitely when it comes to tooling, etc., it's relatively speaking more limited. So I think that's a bit of a limitation of the standard that we rely on RDF. Although I like the standard myself, but practically that sort of finding competence to develop OSLC solutions could be a limiting factor, actually. A positive thing with that is the fact that RDF is, graph schemaless, which is really, I mean, having a schema-free data model is really practical for a heterogeneous, the kind of integration we're doing, where you have very heterogeneous kind of data you want to integrate. So not having to be dependent on a schema is very important. And graph data model is gaining more and more like acceptance. That's fine. But still, this RDF is, it's a bit of a threshold to get people to learn and accept and use, being so limited. Yeah, there's other things that I don't want to go through. Things like stable, having URLs that scares people. That when we have a URL, now all of a sudden my information in the enterprise is out on the internet, which is not necessarily the case. But these are the things that we always have to struggle and try to explain to people about it. But definitely, when you have these URLs, that they need to be stable within your enterprise to make a stable OSLC solution. You're welcome to read my report if you want to talk about the others. And I just want to conclude with some reflections of where I think OSLC, not as a standard, but as a community, where we should go in the future if we wanted this to pick up. We really need more reference implementations. And I don't mean documents of 1 or 2 tools. I mean, OSLC is a promise where, that's meant to be scalable. And besides the IBM tool suite, which is, very good reference, I think we need to show more of these large scale tool chains. And that's a call for our vendors. Maybe you have good customers. Maybe you can show some successful cases where OSLC is being used in the large scale tool chain as a demonstration, because that's the only way we can get more people to adopt this technology. The more we see of it, the more they're going to accept it. So it's got to be proven also in that sense. When it comes to the standard, I think we need a sort of a richer community where you have both the vendors, but also the end user sort of people using our tools and our platforms. Academia, of course, if we can have this kind of heterogeneous, I mean, this is about integration. So if the vendors can talk to each other in this community, maybe we have a better chance of making OSLC pick up even more. At the moment, we're 2-3 organizations that come and go with the standard. I think we need to be a bit bigger and richer and diverse. Something that I found very important, of course, because I'm in the Leo community, I think we need sort of support. We need platforms that make you easy to build these tools. it's my feeling when I looked at the surveys is that everything is being built, sort of from scratch, just, Java, some RDF library somewhere. There should be more and more platforms that let you sort of, pick up and build OSLC solutions much quicker. IBM Jazz, I have a question mark on that because that's nothing you can buy, but that's like, for me, from what I understand of IBM Jazz, that's a platform IBM uses to build them. Why aren't there such platforms, more such platforms where we can build them? I've just discovered this Unite from Persistent, which seems to be that. It's so new, I don't know about it. That's why I have a question mark on it. So we need more and more of these platforms that are available to build our solutions with. Similar thing, we need tool support, like SDKs, libraries are sort of separated from platforms, but just basic tooling that lets you build OSLC-based solutions. A lot of education, I really need to be out there giving workshops and teaching people about the standard if it's going to pick up. So here I give an example, a bit of a biased example, because it's the only one I know of that gives this, and that's the Eclipse Leo open source project for Java developers. But what about the other platforms we have, the other solutions we have? Right, am I out of time?
We're a bit behind schedule, but
okay.
It's,
that's it.
You still have a few words? Yeah, that's it, okay.
Yes, that's actually my solution. Just this is the pointer to the survey. I hope I can keep it updated. Just to look back to this original vision we had, you can join on day 3, where Eric and Åsa will sort of present sort of that particular vision that I referred to at the start, which is not about the survey, but the bigger picture. That's it.
Dr. El Khoury, thank you very much. It's hard, I think, to keep track of all these different tools that exist that support OSLC and to which degree they support it. There are quite a few questions in the Meeting Pulse app. So we're a bit behind schedule. One question: what is the minimum set of capabilities that are required from a server side to be stamped as OSLC server?
I mean, the standard doesn't have any such requirement. I could be wrong here. I haven't looked at it, but there are very few musts. But practically, I've changed my mind actually. Practically, if you do delegated UI for me, then you're there, because that really lets other tools connect to the data you have, create those traceabilities. If I have to choose one, I would say that's the one to provide. I'm not sure what the standard is. Yep. All right. Well,
unfortunately, we have to move on to the next speaker. Thank you very much, Dr. El Khoury.
Thank you.
I'll give presenter rights to the next speaker, who is Andy Lapping, technical enablement specialist at IBM. He has 20 years of experience in model-based systems engineering. I personally have seen many of his YouTube videos on OSLC, and I have enjoyed them a lot. Today, Andy will present how connected engineering data from across the life cycle can be visualized and analyzed using Engineering Insights, which is part of the IBM Engineering Lifecycle Management Suite. So quick reminder to the live audience, you can submit your questions on our separate Meeting Pulse app. You just go to meet.ps/OSLCfest. You can find the link also in the description field below. Okay, Andy Lapping, we can see your screen. Welcome to the OSLC Fest.
Awesome, thank you, Axel. Yeah, welcome everybody. I know we don't have a huge amount of time today, so I'm not going to spend too long on my introduction. As Axel mentioned, my name is Andy Lapping. Suffice to say, I do a lot of stuff, and I've been doing that stuff for a very long time, and that is not my real chest here. Now, I only have a couple of slides to kind of set the scene for all of this, and then I'll be delivering the rest of the session as a live demo. Let's start with the foundation, which is, of course, OSLC and IBM's implementation of that, the IBM Engineering Lifecycle Management Platform, or ELM. And that's a platform that has integrated capabilities like requirements management, test management, design management, workflow management, and so on. It's all built on top of OSLC. It's built on Jazz, so we can connect all of our engineering artifacts to other engineering artifacts for traceability and impact analysis. Now, that's all well and good, but how do we consume that traceability and actually get value from it? Another part of the platform is something called the Lifecycle Query Engine, or LQE. That again is based on the open specification for TRS, Track Resource Set. Now, LQE holds an index of all of our engineering data. Built on top of that are two other capabilities in the platform. Now, one is for building self-service reports, and the other one is for visualizing, searching, and analyzing all of that engineering data. And that is the focus for today's presentation, which is engineering insights. So that's enough slideware. Let's actually go see this in action. So I'm going to switch over to my actual system here. Now, just to give you a little bit of context to what you're about to see, this is actually the product breakdown structure for our demonstration project. It is a drone project, codenamed the Aviary, which is a system of systems. So here at the Aviary level, we have requirements and we have designs and we have test cases. And that system is then broken down into three smaller systems. Right? The drone itself, which we call the Hummingbird. There's a controller, which we call the bird feeder. And then there's a number of viewing devices, which we call bird watchers. Now, if I expand out the Hummingbird, you can see that at that level, we've got requirements and designs and tests for that system. But then that's further broken down into subsystems for avionics and comms and so on. And all of those subsystems have requirements and models and tests. They may have source code and other artifacts. Now, all of that work is going to be managed and planned and tracked through work items. And of course, all of these artifacts are going to be connected by OSLC links. So how do we go about analyzing the impact of a change to a complex system like this? Let's switch to the work item management part of the platform. And here on our team's dashboard, we have a change request here to extend the operating range of the drone. Now, if I open that up and we go look at this links tab, we can see that's got other artifacts from across the lifecycle that have been connected to this work item, of course, using OSLC. And we can see here, it's got an effects requirement link to a requirement in the requirements management part of the platform. Now, if I hover my mouse over that, we'll get this rich hover capability. That's kind of pulling data from that other tool. And it's showing us that that linked requirement is a stakeholder level requirement in the top level part of our system in the aviary. Now, we can also see in that rich hover that that stakeholder requirement is satisfied by two system requirements further downstream. Now, as you saw in the product breakdown structure, right, that's the top of a potentially very deep pyramid with requirements and designs and tests, bill of materials maybe, all at very different levels in that kind of pyramid. Now, of course, these links are traversable, they're OSLC links, so we could follow the kind of thread through requirements management, downstream, and even into other areas like designs. But instead, I'm going to switch to engineering insights, or ENI. ENI gives us a holistic view across all of our engineering data. Now, that allows complex and time-consuming tasks like impact analysis to be performed in minutes, right, instead of weeks. This view, for example, starts at that change request that we actually just looked at in the workflow management part of the platform. And here is that effects requirement link that we saw in the work item management part of the platform. And then here's that stakeholder requirement at the end of that link. And there are the two system level requirements that we saw in that rich hover that were traced up to that stakeholder requirement. But you can see in this picture, we've got all of the other artifacts downstream from those high level stakeholder requirements. Everything in yellow here are requirements at various levels. The test cases are actually in green. The model elements are in various colors that we've used. Now, this isn't just a pretty picture. Right? All of this stuff, these are all live artifacts from the actual tools themselves. So you can see if I hover my mouse over these things, I can get things like rich hover. And in the case of design artifacts, I can even kind of view those diagrams right here in this view. I can also use this view for navigation, because these are the real artifacts from the real tools themselves. For example, if I right click that sequence diagram from the systems design, and I choose to open artifact, Right, that opens up in Rhapsody Model Manager now. We can start drilling down into the detail of the model. Well, let's go back to our view, because obviously this is OSLC. And being OSLC, it's not just limited to our ELM platform. Right? Any tool that supports OSLC and TRS can play in this game. So if you have links to physical elements in a bill of materials in a PLM system, right, they can appear in this view. Devices on an IoT platform, documents in a document management system, as long as it can be indexed by LQE, it can be visualized inside of Engineering Insights. So it's actually quite interesting seeing the presentation from Chad earlier on what tools currently support this stuff. Now that's only one view. All right, views can be dynamic and they can offer levels of abstraction on the engineering data. For example, let's switch to this one. Now this view is one that I built out to help with an ASPICE assessment, but it's actually equally useful outside of that. Over here on the left, in red here, are the requirements modules or documents that exist in this particular project. Now those are actually color-coded based on their readiness. So what do I mean by that? Let's actually click one of them. That's actually going to populate the center panel there with all of the requirement artifacts that are in that module. And those requirements are color-coded based on the test cases that have validated by OSLC links to them and the most recent test execution result of those test cases. Now, only when all of the requirements turn green does the module turn green. Now, green requirements are those where the most recent result of a linked test case is passed. Blue means there's no linked test case at all. And red means that there is a linked test case, but the most recent test execution has failed. So for this module, we can see that there are a lot of missing test cases. And even for those that are there, most of them haven't really been executed yet. But if I click a different module, let's say the Hummingbird System Requirements module, that view dynamically updates. And here we can see the details for that module. Now that one's in slightly better shape in that there are only 3 missing test cases, but there are also more test execution failures as well. But I can see more detail. If I select a requirement in that grid, that's going to populate over on the right-hand side a bit more information about it, showing not only the most recent linked test case execution result, but also the previous execution results of that test case. Right? This is a much more kind of dynamic way of analyzing the data. Okay, one more. This view is analyzing the presence or absence of OSLC links down the V lifecycle on the left and across the V lifecycle on the right. For example, here at the top, there are 49 stakeholder level requirements for the aviary. 11 of those have satisfaction links, satisfied by links to the aviary system requirements, and 38 don't. Right, going down that stream, for the aviary level system requirements, 15 of them have links to downstream Hummingbird system requirements and 16 don't. And of course, you can go across here as well and look at the linked test cases. So for the Hummingbird system, 13 of those requirements are validated by test cases and 26 aren't, and so on. But this view is also dynamic. If I click any one of these numbered boxes, that opens up another Engineering Insights view and gives us a detailed look at that set of requirements. And of course, from there, we could use rich hover, we could go off and navigate into the domain tools as well. Now, in the slides, which I'll share with you after the session, I've included 1 or 2 other sample views just to give you a kind of flavor of the kinds of analyses that we can do when we have that holistic view of all of the linked data. And I've included an example with PLM data being included, and I've included an example with IoT data being included in all this as well. But I think that's pretty much all I wanted to show you. Hopefully I've got you back on track, Axel, in terms of time. But I'll take any questions.
Yeah, perfect. Thank you very much, Eddie. I really loved the demo, and let me quickly open up the Meeting Pulse app to see which questions we have. One question is about the commercial adapters on the market to connect to physical products coming from Dassault systems like CATIA.
So there, I think we can refer to Jad's presentation for a pretty up-to-date list of the tools that actually support this.
That's right. Okay, you don't know if it's a yes or no answer, right? It's
Off the top of my head, I
up.
don't know. Yeah, I have seen stuff from Katia being used with Rich Hover, and the little 3D models come in the Rich Hover. I don't know what the current status is.
Okay. Another question is, can you use engineering insights as the source for delegated user interfaces for all applications that already provide their data to engineering insights? Maybe a tricky question.
I think I understand it. By delegated UIs, I assume you mean the kind of CRUD stuff. You mean using ENI as a way of creating maybe new artifacts in one of the source tools. At the moment, no. As Jad mentioned, actually, engineering insights is only a client application. So it kind of consumes the data, and at the moment you can't use it to invoke things like delegated UIs and create new things. But that is something that I know the team has been looking at as a way of kind of doing things like gap analysis and then filling the gaps directly in the ENI view.
Okay. Well, in the interest of time, we'll move on to the next speaker. Thank you very much, Andy Lapping, for this great demo.
My pleasure. Have a nice day, guys.
I'll give presenter rights to the next speaker, and I also want to remind everybody that if we don't answer any of your questions in the Q&A sessions, you can of course follow up with the speakers in the OSLC Slack channel, and we'll try to really follow up there. The next speaker is Andreas Korf. He is the Director of Business Development and the lead for Systems and Software Engineering at PTC. Andreas Korf has over 25 years experience in the development of complex, real-time, safety, and mission-critical systems. Today, he will show how PTC is using OSLC as base technology for the engineering digital thread. Okay, Andreas Korf, we can see your screen. Welcome to the OSLC Fest.
Yeah, hello. Thanks. I hope you can hear me, so that's fine. I just have, let's say, with a magnitude of 3 screens, I'm currently, let's say, visualizing the wrong one, I think, but I hope you can see my screens anyhow. Welcome. My name is Andreas Korf, as a Director of Business Development and the Systems and Software Engineering Lead. I'd like to present you something about enabling the federated single source of truth for our engineering, let's say, knowledge, and using OSLC as standard. So when we are going into the OSLC idea, I mean, it's a good information to say I'd like to prefer linking instead of syncing within my tools. I mean, the first synchronization I ever saw was in 2000 between models and a requirements management tool, and all of the different problems around the synchronization are pretty clear. Here we have synchronization, let's say, being reduced to the minimum and linking then into other engineering artifacts. Good. So what type of OSLC use cases do we need? And I'm pretty, let's say, it's typical for me to model everything. So when we have a look into the interface using OSLC, the use cases we have is, first of all, authorization to say we'd like to be sure that the data is only be seen by the one who are going to use it. We'd like to see what we need, so show information as delegated UI, and then, of course, creating links. So creating links from the consumer to the provider. And here, 2 things are very important to create: version-specific links, so they are always pointing to the same version, or creating current links within our tool. And how does this feel in, let's say, the context of our engineering digital thread. We have here three elements to think. First of all, digital continuity between all of the engineering artifacts to define our product. So PLM data is extended with requirements and functional logical system design and validation data. So when we have a look into our digital engineering thread, all of these different tools, and they can be, of course, also coming from third-party tools here as well, they all belong to, or they work according their own meta models. So requirements with requirements and so on, links to test data if they are used with the same tool. We have then architectural views. We have then technical and physical views in our bill of material, EBOM, NBOM, and so on. We have, of course, this is a specialty for PTC, our links also to our digital twins, and they have all to be followed in a good way. So in order to include the people for collaboration, stakeholder buy-in, and reuse, we need to have these links here as well. And then, of course, also to automate integration. And this, let's say, is best used using standards if we want to have a kind of best of breed tools.
Andreas?
Yeah?
Sorry to interrupt you. Could you go in full size mode so that we see your slide a bit better?
Okay, one moment. Yeah, well, one moment. I will try to see whether I can switch
in the bottom right.
Okay.
Yeah.
Okay. You mean when I
always.
Well, it's
exactly.
presented on the other machine. I will try to.
Oh, that's why. Oh, sorry. Go ahead then. I didn't want to. I thought it would be an easy, quick solution.
No, actually, it's. One moment. I will try to. Maybe this is, let's say, now working better.
Now we can see.
Okay.
Yes.
Sorry
perfect.
for this.
Thanks.
Okay. Good. If we have a look into our different tools, so Windchill RVNS, for instance, with the requirements, we have also then the capabilities to interlink then, for instance, requirements with our functions. Then we have then, of course, internal to models. If this is, let's say, within one model, we can link this using normal SysML or UML traceability. But if these are different models, we could also link them using OSLC. Then we have the capability of linking our model elements with elements coming from Windchill, PMLink, for instance, and so on. So all of these cross-cutting links, which we need in order to have a federated single source of truth, are either internal or they are links using OSLC. All of our tools, and I explicitly include also our Windchill asset library, which helps to bridge in different component models within Windchill Modeler. They have OSLC provider and consumer capabilities. Good. And if we take the famous V model, then here we have the Windchill RVNS with requirements. We have the physical structure and the software coming, for instance, from Windchill RVNS. We have the tests, validation tools. We have the functions, the logical structure in here, and also third-party tools, of course, and then the physical product. Here in the corner, and that's the reason why I've used this slide, we also included then requirements being connected to augmented reality, where we can see test results then being placed on top of the real products. And so we can see all things which are green are, let's say, okay, which are red are not okay. And this, of course, can be used as an information also within our OSLC toolchain. So here we have the OSLC links. Okay, for the demo, I'd like to switch to my other screen, or let's move it the other way around. So I'm switching here to my VM. This is Windchill or integrity model in 9.2. It will be changed to Windchill modeler in 9.3. Here we have a model with, for instance, certain functions, and they can be shown, like, for instance, here we have functional trees in a block definition diagram. And then, of course, we have requirements. And think of, we do not have these requirements like shown here in our RV&S. And here we have requirements, and we'd like to build up information so we can just go into our OSLC server, have a look at this. A moment, okay. Then go into car infotainment. All of this information here is coming directly from RV&S. And then I can see these functions. And then I see, there is a TV function. So I'd like to have this. And I can have a look at it. I have the delegated UI. I have also the visualization. That's very important. That's very important. And I'd like to build up something in my functionality. So I could just go into the model, say I'd like to have an activity like TV function, okay, which is a part of my audio functions in my multimedia system. And linking is just a dragging and dropping of this element. So I will just get an OSLC link. And they are, let's say, very similar to the links being defined in a system view. So I can say my function should satisfy this functional requirement. And it's all there. Of course, then I can add a callout node to find it. It's, for instance, inside my OSLC link here. Okay, it's here. I can use it. And if the functionality changes or the requirement changes, and I'm typing in something new here. Sorry to have this in German. That was, let's say, the example we are all working around. And then I'm going into my model. We could also automate to have a look at if there are anything. So I'm just doing this manually now, refresh OSLC links. This is now looking for the OSLC links. So we'll go through all of these elements, and it will then hopefully tell me that there are certain things which are which have to have a look at. So let me just see. Okay, refreshing properties. Hopefully it will show up now. My VM seems to have a problem now. A moment.
Very typical of live demos.
Yeah, that's isn't it typical? A moment. I'm just. If I tell you it just worked 20 minutes ago, that doesn't help. Okay, good. Going back to functions. Okay. Well, let's carry on with the other function. What I wanted to show you, it's about, let's say, not the point on requirements traceability. It's more the point on reusing elements inside, for instance, a logical structure. Then you could have, for instance, a functional or a structural decomposition here as well. And so it's again a tree, but I'd like to show you certain elements here as well. So if we are going into this time Windchill, and I'd like to add something in order to have a visualization here as well. So I could go into this element here, say I'd like to have, for instance, every part which starts with D. Okay. That's the IDs. I could also say I'd like to add something which has the title starting with D. Okay. Inside here, I have, for instance, we just heard about the drone camera assembly. What's very nice is in here that we also have then here the option to have, let's say, a current link. So it's always pointing to the element in its current version, or the other versions which exists in Windchill. So I could just go into here, for instance, taking this one, and now I'm using this to create a block as a surrogate. This camera could be also interlinked, for instance, using shared association, and say, like to use it in here. I can have a look at this element. It's now really a block which just states all of the information relevant for me is being placed here in this delegated UI, which is shown here as well. And of course, as Windchill is a web-based tool, I can also take this information here and say I'd like to view a native system. So I can, if I have this link capability, I have this information here as well. So I could directly take this OSLC link as a surrogate and having a look into this element here as well. So I can work within my modeling tool and have this as a link into Windchill here as well. So that's quite good. So we can take all of this information, take our tools, currently Windchill, RV, and S. I'm just opening up these views here as well. A moment, just going back into this mode. So what we just saw is we have the capability of linking requirements from RVNS into SysML model. We have a suspect flagging. We have also parts in Windchill as a surrogate. So I can take and harvest what I have as real elements and use it, for instance, as reusable parts in my logical structure. Okay, good. So when we take all of this, we have multidiscipline collaboration, because we can actually go into the other data sets and reuse what we'll get from the delegated UI. We can see what is available and harvesting from these elements. We have also end-to-end traceability using OSLC and the internal links to the tools, suspect link notification to see what's wrong. We have also version independent and version specific links. And so we can also find problems earlier in the life cycle, although we might not own and use the real tools. Okay, good. So you can see for all of the products of Windchill, RVNS, Modeler, Windchill, what type of capabilities on OSLC there exists. RVNS and Modeler have both OSLC consumer and provider capabilities. Windchill will get a consumer capabilities soon, but has, as you saw, a provider capability. And whenever you have some questions, you can contact me by mail. I hope I'm just in time. Hopefully it's okay.
Yes, perfect. Thank you very much, Andreas Korf. I liked also the live demo, and the occasional hiccup can happen anytime.
Yeah, well.
So that's what makes live demos also interesting. So let me quickly see which questions we have in the Meeting Pulse app. So actually, I forgot to give everybody the reminder that the audience can submit questions on the Meeting Pulse app at meet.ps/OSLC Fest. Right now, I don't see any questions. I have one. Where do you see additional OSLC support in the Windchill tool suite be implemented next? Any roadmap regarding OSLC at PTC?
Yeah, we are currently incorporating the OSLC provider capability in here in Windchill, and there is a kind of tool capability lists also documented on our on ptc.com. What type of capability will come next? Right now, we have the use cases from OSLC for requirements management and system architecture. Change management will come as well. So there are certain points, of course, where we will step by step add OSLC capabilities to our products.
Okay, thank you very much, Andreas Korf. In the interest of time, we have to go to the next speaker.
Okay.
I'll give the presenter rights to the next speaker. Doing it right now. So our next speakers are Peter Lieber and Dr. Horst Kagel. Peter Lieber is the business owner of Sparks Systems for Central Europe, and his focus is model-based systems and software engineering. Dr. Horst Kagel is principal consultant at Sparks Systems. He's a trainer, consultant, and author. His focus is on software architecture, code generation, and the customization and extension possibilities of enterprise architects. Today, they will present the Sparks Pro Cloud server based on OSLC to interact with model repositories. Okay, Peter Lieber, we can see your screen. Welcome to the OSLC Fest. And just a quick reminder, please, to the live audience, please submit your questions on the Meeting Pulse app at meet.ps/OSLC Fest. Thanks. Peter Lieber, go ahead.
A warm welcome from the warm Vienna. So we keep distance, so it's 1 meter, but we decided to use the better capabilities of internet to be able to make some live presentation too. So first I give some introduction on OSLC in Sparks Pro Cloud Server, and then we will hand over, I will hand over to Horst to make some deep tech stories and show a little bit more. My name is Peter Lieber. Thank you for the introduction. I'm also not only working for Sparks Systems, but I'm also the president of the Austrian Association of Software Industry, which makes me very proud because it's 6th year in a row. And in these heavy times, it's very important to have relationships and any kind of association to help. And so OSLC Fest too. So thank you for doing a lot for OSLC. A short introduction to Dr. Horst. Yeah.
Sorry to interrupt you. We can actually see your next slide in a small preview window.
Okay.
If you could go in full size.
Completely off. Turn off presenter mode. So thank you for.
Sure.
Ja, ausschalten. Ja, du musst. Gehen Sie.
I just always click on the bottom right button,
Yeah.
slideshow button on the right.
It should work again, but it's not turned off. So interesting. Different use in monitor. One. Memory monitor. And now we have it, hopefully.
Yes, this looks very good. Please continue. Thanks.
Thank you, too. Just to have an idea, Spark is a global company headquartered in Melbourne, near Melbourne, Australia. It's Creswick, but Creswick nobody knows. But Melbourne, everybody knows from Formula 1 and tennis, of course. So whatever you prefer, Melbourne is the first in the row for such international events. We are headquartered in Vienna, in Austria. So and responsible for Central Europe, except Britain. Once again, I will start with a short deep tech overview, and then we have a live session how to interact with the model using OSLC. So it will be some coding. I will not explain what OSLC is because you know it very well, so just can jump over it. But what is very important is what are the capabilities of ProCloud Server in regards to OSLC. So currently, we have implemented the Architecture Management 2.0 functionality for service provider resources. We have URIs, RDF, XML representations, including some custom fields. Using the REST services, API, the resource factory, a resource query capability, link type query capability, partial resource update, selective properties, and error response. So what does it mean? We have, of course, these references to the website, just to know which I exactly mean. And for integration of data, we use the linked data standard. Enterprise Architect acts as an OSLC provider in these circumstances. And Enterprise Architect is the tool we use, and we use as a proxy ProCloud Server, which is the middleware of it. And we have currently, we are only provider, just to let you know, and not the client so far, but we have implemented already the linked documents capability. We name it integrations, but we've used the OSLC standard for linked documents also on server side. Why we want to jump in is how the server provides providing interfaces are looking like. So it's also a trial session, but you should know that the Enterprise Architect provides the ProCloud Server, and this one has by default a web server inside. You must not use the web server that is inside, but by default it's activated. And there you have 804 as standard port. And what is very important if you want to access a repository, that you have a login capability. And you can use OAuth, but if you want to use the internal things, then you have a proprietary possibility using also OSLC to get the handler for interacting with the interface. And so we are using this with the post body, and we use the UID for the user experience, the user ID and the password as a post body for accessing the infrastructure, and then we get the user token for interacting. What we additionally support is that we have a creation factory to create new resources like packages, elements, and connectors. You will see this later on, what are packages, what are connectors, what are elements. And we have, beside the default modeling aspects, we have also resource features like discussions, discussion replies, resource allocation tests, tag values, maintenance items, and project management items. and of course element attributes, operations, and parameters. So it's not only the modeling capabilities, but also the surrounding elements. So you can access everything that is in an enterprise architecture repository using OSLC, and you can make this CRUD, meaning create, read, update, and delete. Delete with some restriction, but it's possible. Here is a sample of how to create a new class. It is because of a documentation purpose you can read through, but we are using these create capabilities, and then it's updated also automatically in the data. To read an element, you have to give an URI, and we have here a specific link where we also declare what kind of element we want to read. We have internally GeoIDs, and if you want to read an element, we have a prefix that is naming already the element, if it's an element, a diagram, and so on and so forth. Additionally, we are using this RDF XML representation, and we have some enterprise architect specifications because we use OSLC says we use HTTP put, but we use HTTP post. So we will have we have some incompatibility, but it's only a minor thing from our perspective. Just to have an overview which kind of elements we are supporting. So this a thing called model root, packages, elements, diagrams, and links, and all the other are named here and are prefixed. And of course, the interface for querying elements is also implemented, where we have a where attribute, and this query syntax is also following the syntax that is provided by OSLC. It's near to SQL, as you know, but it's working very well. Currently, we have implemented for full functionality. Enterprise ID provides 60 modeling standard, but to support creating elements with all the profiles, it's currently only available for the 4 named ones. It's Archimate for enterprise architecture, BPMN, business architecture, GML for geographic architecture, of the systems engineering, and of course UML. But currently there is a restriction that not all languages are 100% supported, except the ones that are based on UML. But this was my short part. I try to hurry because my colleague wants to show something fancy in the presentation.
Now, I would like to show you the current setup. I would like to tell you that what you see here is Enterprise Architect, the modeling tool, and the diagram shows the setup I'm talking about. So here we have the Enterprise Architect client, which is what you currently see. Enterprise Architect is currently connected via ProCloud server to a database behind. I would like to introduce now 2 OSLC-based clients. One is called WebEA, and one is called OSLC client. This is just a SketchUp to see what's happening behind the scene when we use OSLC. So I will start with the OSLC client. This is this one. Here I have a few configured links to models. The first one is called Hugo on SPX E02 with an initial OSLC query, which provides me the root of the model. So if I'm executing this query, so I will get the result. You can also see it in plain text, so it's just the RDF XML we are getting here. If I switch to XML, I can browse it. So what we see here is we have 2 resources. Both, or the first is called model, the second is called trash. Both of them are type is model root packages. Model root. This is what we see here in Enterprise Architect. This is the model, and this is the trash. And here inside we have the Spark Systems namespace SS, which allows me to create the nested sources. Here I can follow this link, just paste it and perform another OSLC post and get the result. What I see here now is the content of the first package, requirement package. No, sorry, first of the root model. So these are the three packages. First one is called requirement. Second one is called system model. And the third one is the architecture. Good. Here again, we have the Spark system specific namespaces, which allows me to trace further. But I can also use this resource and create something new. So here I will create a new requirement. This opens a new user interface, which allows me to enter a few data, like requirement name and the nodes from client. Good. Now I have created this new element. Now we can have a look at Enterprise Architect, the FET client. I will select this package. This is the one I have created, the new requirement element. If I update this package, reload, then I have my new requirement here with the nodes. And as an author, it's the OSLC client I'm using. So this is how we can browse the model, create something new. But we can also do it with another client, which is called WebEA. It's a web-based client. So if I open this one, here we go. So if I'm logging into this project, I get a more user-friendly representation of the data.
And it's all using OSLC.
Yeah. So this, in the back end, we are also using OSLC, but the OSLC data are now integrated in a more user-friendly way. So we get, again, these two root packages. I can browse the model. And also, I see here now my newly created requirements. Okay, this was a presentation.
Are there any questions? I think we are in time.
Okay. Well, Peter Lieber and Dr. Horst Kagel, thank you very much. Let me quickly check on the Meeting Pulse app which questions we have. Just refreshing the page. So one question is about the support for OSLC configuration management. Can you say something about this?
So currently, we have only the capability to access the current models, because we have a specific way to store configurations in baseline, and baseline is just another detailed information in a package. So currently, we have no support for it, but we are having it as a thought on the roadmap.
Okay, all right. Let me go to the next question. Is OSLC support available even if my Enterprise Architect UML models are saved locally on my own computer? If so,
No.
how?
No, it's not available because the OSLC capability is implemented in ProCloud Server. If you have the free edition of ProCloud Server, then it's only the OSLC requirements interface, so only for requirements elements. If you want to have the full-blown capabilities, you need at least a token, which means 99 euros a year per token, per user.
Okay, thanks. Another question, is that OSLC client that is being used a proprietary product or some community product?
This was just a prototype we built from last week to this week to make it more user-friendly than having a Visual Studio environment. So we are thinking about promoting it as a community edition just to show the capabilities. It's not really it's a real developer tool. Let me still let that.
Okay.
Only built for
Peter
this.
Lieber. Yeah, please. Yes. Okay. Sorry, I cut you there off. Well, we're on time now, and we'll move on to the next speaker, Peter Lieber and Dr. Horst Kagel. Thank you very much for your presentation and the live demo. I'll quickly give presenter rights to the next speaker. And the next speaker is Robert Baillargeon, Chief Product Officer at Sodius Willard. Let me double check first that Robert can share his screen. Okay, he's ready. So Robert Baillargeon is Chief Product Officer at Sodius Willard. He has a lot of expertise in developing systems in the automotive industry and in leading research projects. Today, he will present the OSLC Connect for Windchill solution to achieve interoperability between ALM and PLM. Okay, Robert Baillargeon, we can see your screen. Welcome to the OSLC Fest.
Thank you very much, appreciate it. And thanks everybody for staying online. I know we got a busy session for some folks that are early in the morning and others it's in the afternoon. And thanks for taking time spending with us today. I got the last session, so I think that means Axel will let me go as long as I want, right, Axel?
Not quite.
All right. We'll try to do a tight 20 minutes today and show a demo and give you a little bit of background and be able to answer your questions. So Sodius Willard, we're a global company. We've done interoperability for the last 20 years. When we talked interoperability 15 years ago, it was how to be able to exchange information between tools. So doing synchronizations. The last 5 to 10 years, we've fully embraced OSLC as a way to be able to bridge the gap more effectively and be able to make our teams much more successful in sharing information between enterprises as opposed to synchronizing data. And so really our mission within our organization is to integrate the engineering enterprise. So make sure that teams have the tools that they need to be successful, have the data that they need to be able to dream those ideas and be able to connect them together so they can focus more on creating the product they want and less on being able to create their tools to work together and synchronize their data. And when we talk about integration, OSLC very often has been focused much on the ALM space, but we're talking about some of the integrations with the PLM space as well. And I'll talk generically about that, and then we'll give a little bit of an example here in a few minutes of something very, very concrete. But as we work on our own OSLC Connect for Windchill product, as we work with our partners on other OSLC connections to other PLM solutions like Teamcenter, there's some common themes that we have when we start crossing that gap between ALM and PLM world. And we need to understand that so we know how PLM fits in that OSLC space. PLM, as Axel said, I originally came from automotive, so I spent about 20 years working in automotive, running process and tools. We know in automotive, aerospace, and defense, and others, the PLM system runs the enterprise. It's the main system of record. It has a huge scope and impact on the organization, and it's highly customized to their business. And so we know that the way it operates is unique and different than other systems, and we need to work in the way that it operates because it's actually driving many more of the engineers than maybe our ALM spaces and many of our product-driven companies. And we know one of the critical points in which we connect is that the elements of configuration management. So how things are stored, how things are versioned, and how we identify those configurations, they're unique, they're different. And what we critically want to do is be able to make sure we understand what's different between those systems. And so trying to distill the last 3 or 4 years of operations as we work with these PLM solutions, we've identified quite a few things that we think are important. Number one is when we talk about the system of record, the PLM systems in many organizations are the golden source for almost all data, meaning that not only do they have their core data included in there, they also have long-term storage of other data. So they might be able to take models or other data and capture them in terms of importing them in the PLM solution because that is the golden source of where we want to manage that data, or where they want to manage that data. And configurations themselves are managed together with the data together. So not only do we have versions of elements, but we have hierarchies of elements. We have hierarchies that contain versions. There's a different structure to the data that we have. We also know that working with these PLM solutions, oftentimes they're much more copy-based in how they interact with the outside world in terms of synchronizations. Lots of internal links, but that's not typically how they work externally, even though we're seeing some changes with that. And we have this intermix, and we see this in the BOM structures and the versions of information, that we have hierarchies that identify what other versions, what other parts are contained, but they also contain versions, and we need to manage those configurations. So it's a little bit different how we relate it. And when we come to versioning, AOM often comes from kind of a systems and software perspective. So the way we look at versioning is often founded on the way we might look at software configuration management systems. But when we look at PLM versioning, especially on the parts basis or document basis, we're going to version artifacts singular. So a single part will version, it will version linearly. We might branch it, but we never merge that data. So we manage those things in a single stream, and we can reuse those individual artifacts many, many times. And this goes into how we want to be able to reuse this in the OSLC space. And we know that these artifacts, these parts, look very similar to OSLC resources. Interestingly enough, they also look very similar to components because each of these versions are also their own unique sets of baselines. And so it gives some context for how we want to map the concepts that we have core to PLM into how we might want to implement those in OSLC. Now, the configuration strategies are also a bit different. When we look at a tool like Git or Subversion or even RTC configuration management, when we look at doing configurations, we have streams, we have branches, we also have tags or abilities to be able to stamp a particular set of static artifacts to be able to say these are baselines that we want to use later on. In a PLM system, the way we do configurations is often very different in terms of the way we do it is much more a mixture of both structure and version, but also we're going to be able to apply filters or selection criteria to be able to pick which artifacts are actually contained within a configuration. To that extent, things like effectivity, so what are the parts that were effective 3 months ago, that's actually a selection criteria or filter, and so we calculate what elements might be in that configuration rather than creating a static application of configuration. And so what we want to be able to do in these types of systems is blend these two together. It means these PLM configurations that we have externally look much more like local configurations that we project from other OSLC tools. These PLM projects are going to look like containers in which we store these components and these configurations. And most importantly is we need to have these PLM configuration participate in the enterprise and be able to look at more of an enterprise configuration management solution of how to synchronize or how to align for a particular purpose, how these configurations work together across the entire enterprise. And so probably visually, one of the best ways to do this is to talk about how we might do configurations and how we use configurations in the OSLC world from the PLM space. So when I'm a part designer, oftentimes I'm not looking for the rest of the product that I'm working on my singular part. And my singular part has relationships. It might be to an FMEA, it might be a particular requirement, but I'm going to want to be able to create a link to that artifact. Now the question is for this part instance, this is instance A1, what version of those requirements do I want to map to? And what these are a configuration that I might be working with. And we think of this configuration as a as designed configuration, meaning that as I design this part, these were the sets of artifacts I designed to. And so this part might be used many times in other places, but there was always a singular set of artifacts in which I designed to be able to make sure my product was going to be, my part of that product was going to be successful. Now, we also know that there's another view, or at least one other view of the system, which is to say, when I look at the larger set of the things, in this case, the holistic golf cart and the sets of parts that are contained within it, I also have relationships, and these relationships are going from those sets of requirements and what parts do they actually impact. So in case that requirement changes, or if I'm actually building a particular product, in this case, this next version of the golf cart, I'm going to want to be able to understand those relationships to be able to contain those in. And so we can think of this as a larger set of relationships, meaning that these are the global configuration. This is the enterprise configuration that pulls together not only my specific physical parts and entities, but also the entities that are associated with software systems, design, test, to be able to bring those things together. And we need to have both of those worlds together to get AOM and PLM to work together successfully. Now, so what does it really mean to be able to bring PLM into the OSLC enterprise? We need to be able to treat these assets as configurable elements. We need to be able to understand the difference between as designed and as used from a configuration standpoint. So we can be both configuration aware, meaning when I'm working on my specific part, I know and I can identify which requirements I used in that design, so that when I baseline and release that part, I always have that traceability. But I also want to be able to relate and utilize that as a participant, meaning that when I use a particular part in a product that I deliver as a holistic entity, I can get back to what requirements were applied, what test cases were used, what were the test results, and be able to have that full traceability vision for that whole digital thread. And it also means that it's mandatory for us to have an enterprise configuration manager. Oftentimes with our PLM systems, we think of them as holistic. As we decide to link outside of this PLM system, we need to externalize what this configuration manager is, so it can provide the facilities necessary for people to be able to manage what version those links actually navigate to. But I think ultimately out of this, what it does is it reduces the burden on our PLM system as the only enterprise repository. It allows us to be able to take in our IBM environments, our Jira Atlassian environments, our other tools and our other systems together to be able to better reflect what the enterprise is from a design perspective and better manage these engineering elements together. So that's kind of the big picture of this. And when we want to do this, we want to be able to talk about this more kind of pragmatically in detail. And so let me kind of talk a little bit about our OSLC Connect products, because what we try to do with our products is be able to provide these integrations and allow engineers to work where they're productive. So they're not forced to use one tool. They can use any tools that are interacting in the OSLC enterprise. We talked before about how engineering organizations are often very customized for their needs. We're not going to proffer off some specific usage scenario. We want them to be flexible to the needs they have, and that's what OSLC really provides. And most importantly, we need to have tools that work in the enterprise, meaning that they need to meet the security demands. They need to be fully integrated with the source technologies and source tools, so that just as well as the engineers can use it, the IT teams can deploy them. We work very much with aerospace and defense, so we might have firewalls, we have reverse proxies, we might have high availability demands in the system. We need to work with that within this OSLC space. And so our OSLC Connect products, we're going to show you Windchill now, but we also have a Jira solution as well. What we focus on is having deep integrations with the tools. We don't want them to look and feel different than the technologies that people are using today. We want them to just become OSLC enabled. We're targeting all the different OSLC tools. I think the work that Jab is doing in terms of taking a look at the enterprise and where it's going and where the community is going is important for that. And we do that tremendously internally to do those testing and validation with all the tools that are out there. And really what we want to be able to do is deliver on this digital thread. From how do we get from our top level products, our parts, all the way down to the end systems. So we're going to do a quick overview here, because I know we got about 7 more minutes here, and I think we can get a demo in here that shows some interest. But we're going to show parts of our Windchill integration. So we're going to see a deep integration with Windchill, parts and links into requirements to be able to show that traceability, as well as working in a concept called being configuration aware. So we can look at, for a particular part version, how does it relate to the differences of the requirements on the different configurations that it's operating on. And I think that will give you a wider idea in terms of what's possible with OSLC, what's practical with the PLM space, and give you a little bit of look and feel of how it really operates. So with that, let me transition over and hopefully Andreas got rid of all the demo gremlins, because we all face that whenever we're doing live demos. And so let's see what we can do here. So in here, we're going to show you this is basically a Windchill environment. And the only thing that we're doing in terms of extending this OSLC capability is this simple tab over here. So I'm looking at a single part here. It has a set of requirements. We're going to see this rich hover. This happens to be Doors Next Generation, which is the target. We can see information about this. We can do the rich hover. We can navigate to it. We can see those artifacts there. As we look at different requirements, one was a module, one's just a simple requirement. We're going to see the differences associated with this. As you can see, I also have a configuration down here, which is to say that this configuration, Computer 1.0, this is the first version. This is setting which versions of requirements and which versions of other artifacts that I'm related to, and it's being able to use that dynamically to be able to say which configuration should I have. And this is, you can consider this is the as designed concept. So as the engineer went through, this is what they were designing to. Because you also can see here that we're on version 8.2, which isn't actually the latest version. If I go to the latest version of the product, we're going to see some changes, which is to say that you'll see these artifacts dynamically update, which case that we can actually see the requirement is actually updated in terms of its content. So did the module in terms of its name, because it's actually using a different configuration. So this is important for us. As we work and as we operate, we can identify those artifacts and be able to identify which versions of those artifacts that we navigate to, and be able to create those linkages and provide that information. And obviously, as we operate through here, we can go ahead and use those natural elements within the OSLC space to be able to create relationships. So if I want to be able to create a relationship to a requirement, I'm going to get the delegated dialog from Doors Next to be able to go search and find the artifacts I want to relate to. So if I want to be able to create those links, I could. Now, in addition to that, if I go to navigate over to one of these requirements, which I can just by clicking on, which is the wonder of OSLC, I have the ability to be able to simply navigate to a new artifact just by clicking on it, switch between different tools, and you'll be able to see here, not only do I have a set of artifacts, these are actually my links back into Windchill, so I'm going to see a preview back to my parts back into Windchill, so you can see if I go to change this document, I actually impact several different parts, a DVD drive as well as the desktop. And I also have links back into, in this case, happens to be Quality Manager, which has these test cases and test plans that are back and related to this. So I have this full traceability that can navigate in between different tools and technologies very simply, very easily, and be able to see that information instantaneously as we walk back and forth. And as changes take place, there's no synchronization of data. Each time that I do a rich hover here, it's going to update and be able to bring in the latest, greatest information. For example, if I went over to this requirement here and went ahead and did an edit, and went ahead and went back to that part, simply being able to update and be able to do the rich hover, it's going to be able to grab and be able to find that new information. So even if I don't actually do a active refresh, simply just by hovering it, I'm going to get the latest information. So people that are interacting with this, anybody who's interacting in your enterprise is always going to get the latest and greatest information back and forth. So that kind of gives you an idea in terms of parts and configurations. The other thing in this world that we know is that change management is richly important. As we do product level changes, they trigger down to tools like RTC. They also trigger down to tools like Jira as well. So you can actually see, if I do a login here to my Jira system, that's also enabled by OSLC, we're going to see updates of those Jira artifacts and be able to see the status of those immediately natively within our tool, just because we're doing OSLC. And I can even navigate over into these Jira tools and be able to see this as well, and be able to see the rich hovers back into Windchill. So this is kind of the big value proposition of OSLC is not only can I work with different types of tools and different capabilities of tools, I can interact with an Atlassian system, an IBM system, a PTC system seamlessly and navigate back and forth. So I think that's the vision, that's what we're delivering to our customers. And the most important thing I think from the PLM space is that configurations matter. And so when we think about these parts and these part versions, we also need to understand that they actually operate within a particular configuration for being as designed. And as we look from the other direction, which is in the global configuration, you're going to see I'm working in computer 1.1. That's going to tell me which of the parts are actually participating in there and related to this artifact. So it goes both directions, and we need to respect those different relationships that we might have. So with that, that is probably, if anybody knows me, the quickest and shortest presentation you'll see me give. So thanks everybody for the time. If we have any questions, Axel, I'm happy to answer them here, or free to be able to reach out to me directly and be able to ask us and talk to us about what's going on in the PLM and ALM space with OSLC.
Okay, Robert Baillargeon, thank you very much. Great presentation. I really liked how you talked about configuration management in PLM and also the need for an enterprise global configuration management solution. On our Meeting Pulse app, where the audience can submit questions, I can see one question. I'll read it out. Did you use the OSLC architecture management spec to perform this Windchill integration?
Yeah, so that's a great question, and I'll actually go back to, I think the discussion was before of the surprise about people not using custom profiles. We did use the architecture management spec for two reasons. Number one, I think that it is probably the best fit when it comes to our Windchill information in terms of parts, to be able to capture that information. But not only do you provide those artifacts in terms of using architecture management, the tools you want to connect to have to be the ones that consume those same standards. So when it comes to requirements management tools, they typically support consuming architecture management, and it allows us to be able to integrate with a wider set of tools and technologies because we use architecture management. So that is probably the prime place. Obviously, I think that there's some challenges out there in the OSLC space of how to be able to do more flexible profiles because there might be some more growth that takes place. But architecture management right now is a very good fit for both its capabilities as well as the consumption capabilities of other tools, so what it can connect to.
Thanks. One final question. Is this OSLC integration built on top of open source libraries like OSLC4j, or is this built on top of proprietary libraries?
Well, I think in any time somebody does development, there's a mixture in terms of open source technologies and proprietary technologies. We take great pride in terms of being able to adopt what's good and capable in the field, as well as when we talk about doing deep integrations with the tools, we're oftentimes leveraging the extension points that are native to those tools themselves. So it varies from product to product, whether for our Jira product or our Windchill product, but we definitely leverage the technologies that make sense to be able to build those products and deliver them to the market.
Okay, Robert Baillargeon, thank you very much again. We have reached the end of the OSLC Fest. This was the last talk today. I want to give a very warm thanks to all the presenters. And I also want to thank all the viewers who followed us live and who submitted questions. I invite you to join tomorrow for the second day of the OSLC Fest. You will learn more about the OSLC Open project, about Eclipse Leo, as well as other solutions from tool vendors supporting OSLC. You can check out more, of course, on oslcfest.org if you want to learn more about the agenda. I also invite you to check out the links in the description field below this live stream, where you will find links to the OSLC website, to our OSLC forum, OSLC Slack workspace, where you can follow up with speakers and ask additional questions. And very importantly, also, you will find the link to the live stream for the second day of our conference. And I hope to see you tomorrow. Thank you very much for joining. Have a good day. Bye.